Yeah, welcome guys. In this lesson we'll be treating intermolecular forces. So let's head into the lesson straight up. So first, what are intermolecular forces? So intermolecular forces are forces of attraction or repulsion that exist between molecules. So these forces are responsible for physical properties of substances and physical properties such as melting point, boiling point, and the solubility. So unlike covalent and ionic bonds, which occur within molecules, intermolecular forces occur between them. So what have I been saying so far? So we have been talking about the different types of forces that come in play when we talk about atoms coming together to form molecules or compounds. So and for this reason we've been talking about metallic bonds, we talked about ionic bonds, we talked about covalent bonds, and we talked about several kinds of bonds. So now there is another force that comes into play in keeping molecules together or keeping atoms together in a particular molecule. So this particular force is called intermolecular force. So there are forces that are kind of like attractive or could be repulsive, and they exist between molecules. So unlike the ionic and covalent bonds which occur inside a particular molecule, ionic and covalent bonds and those their likes, they occur atom to atom, that's within a molecule. But intermolecular force of attraction is actually a force that now we've left inside the molecule, now we've come outside the molecule. So it's the attraction between one molecule, or probably one molecule of water with another molecule of water. So the kind of forces that come into play that tries to keep them together. So let's head deeper into this lesson. So there are several types of intermolecular forces, and we have London dispersion force, we have dipole-dipole interaction, we have hydrogen bonding, and also ion dipole forces. So these forces, they vary in strength and they arise from different types of molecular interactions. So these forces influence whether a substance is going to be a liquid, solid, or a gas. So these are the molecules. Just take note, they are the forces that actually exist between molecules. So ionic and bonding forces that we mentioned earlier are the ones that try to affect the formation of molecules. If I would say it that way, yeah, they affect the formation of molecule. That's atom to form a molecule. Then now after you've zoomed out of that, there is now we form the molecule now. So we now have a molecule and another molecule. What can now keep these molecules together tightly or keep them together loosely, which would make them either solids or gases. So that's all we're talking about, and there are different forces, and we have the London dispersion force, the dipole-dipole interaction, the hydrogen bonding, and also ion dipole. So we'll be discussing more about these forces. So let's see. London dispersion forces. These are the weakest molecular forces, and they occur in molecules, particularly non-polar ones. So they occur mostly in non-polar molecules, and they arise due to momentary fluctuation in electron density that create temporary dipole. So they are not really they are not basically dipole forces, but they are formed as a result of temporal dipole creation when let's assume the molecular density, or sorry, the electronic density for some kind of molecules where the electrons can move from one side of the molecule to another side. So when the electrons are making these movements, they kind of create a kind of charge variation between along this molecule. So when the charge, probably when the electrons are at the left, the positive sides will seem positive. When the electron then moves back to the right, the negative side, the former positive side, the former negative side will become positive. So this kind of movement, this kind of fluctuation in electron density gives what is called a kind of temporal dipole to that molecule. So due to this variation of dipole, or this fluctuation in electron density, it leads to the existence of these London dispersion forces. So despite their weakness, they can be significant in large or heavy atoms or molecules. So let's see what we have next. Next we have dipole-dipole interaction, and this kind of interaction occurs in polar molecules. So for London force, it actually happens in non-polar majorly. So for dipole-dipole, it happens in polar molecules where there is positive end and also a negative end on different molecules. So when you have probably a molecule that has a positive end, then we have another molecule that has a negative end. So these molecules, these different molecules, their positive and negative ends will tend to attract to each other, and this kind of attraction would lead to the formation of this dipole-dipole interactive force. It will lead to the creation of this dipole-dipole interactive force. So these forces are stronger than dispersion force or the London dispersion force, and they influence boiling and melting points of polar compounds. So they also strengthen, their strength is also dependent on polarity of the molecule. That's the strength of the polarity. These two molecules now that we say one of them has a positive, the other has a negative. So depending on how polar these molecules are, it would also determine how strong the dipole-dipole interaction would be. So with that being said, let's see what is next. The hydrogen bonding is another type of molecular interaction. So this hydrogen bonding is a special type of the hydrogen bonding is a special type of dipole-dipole interaction that occurs when hydrogen is being bonded to highly electronegative atoms such as nitrogen, oxygen, and fluorine. So these three atoms are specifically one of the they are among the most electronegative species on the periodic table. Hydrogen, oxygen, no, not hydrogen, fluorine, oxygen, and nitrogen. Fluorine being the highest, followed by oxygen and so on. Though there are some other electronegative species, but mostly these particular types of species, fluorine, oxygen, and nitrogen, they are the ones that give rise to the formation of hydrogen bonding. So the hydrogen atoms become strongly positive because these electronegative species tend to pull off all the traces of electrons on the hydrogen end. So we have hydrogen bonded to maybe hydrogen bonded to fluorine. So as a result of this hydrogen being bonded to fluorine now, we would then see that fluorine would attract more of the electrons that are on the electron density on hydrogen, and for that to now make hydrogen seem like as if it has lost its own electron completely. It did not really lose it, but it would seem like it has lost its electron because to now have a kind of net positive charge because it's lacking its standard electron from its normal neutral state. So for this reason, it has formed what is called a polar molecule. So this hydrogen atom becomes strongly positive and is attracted to a lone pair of electrons on the negative or the neighboring atoms. So we have hydrogen being bonded to fluorine, and the hydrogen becomes positive, the fluorine becomes negative. That's one molecule. Then when we now have several hydrogen and fluorine molecules, it will then form something like the hydrogen on one molecule will be trying to get acquainted with the fluorine on another molecule. So this kind of continuous interaction is what is called the hydrogen bonding, and it results in a kind of strong intermolecular force of attraction between molecules. So the next is going to be ion dipole forces. So these ion dipole forces occur between an ion and a polar molecule. So this one occurs between an ion and a polar molecule. So other ones probably are happening between two molecules, and between two molecules. London dipole force was between two molecules that where one of them or both of them they kind of have a fluctuation in ion density. Then we add dipole where one of them is a molecule that has a negative end and the other one has a molecule that has a positive end. Then they interact. Then we talked about the hydrogen bonding where hydrogen is being completely negative. It's a form of dipole bonding. So it's kind of a form of dipole interaction. So hydrogen then becomes positive end, then fluorine becomes negative end, then it begins to bond with other portions of the fluorine in the system. So that's for those ones. But this one now, it's not just between molecules, because those other ones were between different molecules. But now in this case, it's between an ion or an ion and a dipole molecule or a polar molecule. So these are important in solutions of ionic compounds rather, in polar solvents like water. So this is the thing that is responsible for the solubility of salt in water. Common salt, that's NaCl, the solubility of common salt in water, because common salt exists as sodium ions and chlorine ions. So they are ions, they exist as ions, their crystals exist as ions. So then water exists as a polar solvent. So when we have this kind of mixture where we have an ion and a polar molecule, there is a kind of dissociation that happens where the positive or negative ion gets to interact with the partial charges on the solvents of the molecule, that's the polar molecule. So the negative or positive ends of the sodium or chlorine would then attract to the positive and negative portions of the hydrogen, oxygen, water molecule. So stabilizing the solution and enhancing for solubility between the two compounds. So let's see. In conclusion, understanding this intermolecular force of attraction is essential in explaining a wide range of physical and chemical phenomena, from why water is high in boiling points to certain reasons why substances are soluble in other substances. So these forces kind of underpin many concepts in chemistry and are foundational to material science and biology. So we've come to the end of this lesson. Bye.